in the macrostructure as the way in which the tree interacts with the world. So in nature, there are three ingredients that allow the universe to defeat, this pessimism of Boltzmann. And these are the three ingredients that allow information to grow. The first one is that information is not free. You need to spend energy to generate information. To create information, you need to be in an out-of-equilibrium system. Second, you need to have solids, because without solids, information cannot endure. It will not last. And finally, you need to have this computational capacity of matter. Matter develops a capacity to be able to recombine order. At the beginning, in very simple chemical systems, but then that capacity gets re-embodied in life, and as we will see later, it gets re-embodied in society. And those are the three ingredients that allow information to grow. But what this also tells us is that even though these ingredients might not be able to help us explain the complexity of society, they tell us something about it, which is that information is always going to be able to exist and grow only in little pockets of the universe. Because when you look at the universe at large, the universe is going to be going in the direction that Boltzmann described. And the only way to cheat the universe and to be able to generate physical order, to be able to create information, is to actually do so in little pockets in which you are spending energy, you are creating solids, and you are computing to help information grow. So what we're going to see next is we're going to see how these mechanisms by which nature generates information get re-embodied in society and the economy. So the first thing that we need to understand the information that grows in society is the difference between the information that existed in nature that I described before and the one that we generate as humans. And as an example, I'm going to tell you a story that comes from being an expat. So I'm a native from Chile, and when you live in a country that is different than the one that you're born, you frequently visit the newspaper, of your foreign country. For instance, my wife is Russian. She will go and visit Gazeta.ru, very regularly. Now, I was looking at a Chilean newspaper, and I was looking at the business section, and there was this news that says Chilean had bought the world's most expensive car. I noticed my reaction was like, whoa, what a douchebag, who would spend all that money in a car and show it off? But after that, I started to think about, how much is that car worth? What car is it? And the most interesting question is, how much is 1 kilo of that car worth? And the car was a Bugatti Veyron. At that time, it had a sticker price of $2.5 million, and that is $1,300 per kilo. So that's kind of expensive. So what I'm going to do here is going to invite you to do a thought experiment, and imagine that you just won this car on the lottery. You won this car on the lottery, you're very excited, you take it out for a ride, but all of a sudden, boom, you bump it against a wall. And now the car is totally destroyed. Obviously you escape unharmed because the car has a very good safety system, but you don't need a PhD in economics to know that the price of the car evaporated when you crashed it against that wall. So what does this example teach us? Well, this example teaches that actually the value of that car was not embodied in its atoms. It was not in the matter, but it was in the way in which those atoms were arranged. It was on physical order, and that is information. So we now have a basic idea that economic value is related to physical order. It's related to information. But what type of physical order and information is the one that actually generates physical value, economic value? So let's look at a different example in which we're going to compare apples and apples. On your right, you have the apples that you buy in the supermarket, jablaka, and on the left, you have the apples that you use to check your email. And the question here is, what is the big difference between the apples on the right and the apples on the left? And you can argue that maybe the difference is in price or the difference is in complexity, but in reality, the true difference between these two apples is that the first one, the apple that you buy in the supermarket, was one that appeared first in the world and then in your heads. There was a world in which there are apples before there was a market for apples, before there was a name for apples, before there was a price for apple. The second apple is very different. Actually, it was a product that existed first in someone's head and then in the world. So the second apple tells us that actually, the world is made of crystallized imagination. Our world, even though it's real and it's tangible, is actually made of things that started as fiction. So to illustrate this idea of crystallized imagination, let's look at two examples. One is an office environment, and is the way in which office environments look like 20,000 years ago. So 20,000 years ago, an office environment looked like this. And this office environment was definitely not information poor. In fact, here there was a lot of information. There was information embodied in each one of these people, in each one of the plants, in each one of the microbes that populate the soil, in which these people are sitting. The difference between this environment and a modern office environment like this one is not that the first one has less information than the second one, it's that they have a different type of information. The second office environment is made of crystallized imagination, because all of the objects that make our modern office environment, are actually objects that were born first in the virtuality of our minds. Now, the nice thing about thinking of the world in terms of crystallized imagination is that it helps us understand important economic process in a new light. So as an example, let's consider the products that Chile exports to South Korea. This is a visualization that is created in the Observatory of Economic Complexity, which is a tool that visualizes all international trade data that we have created in my group at MIT. And what you can see here is two things. On the one hand, you can see that Chile exports $4.6 billion to Korea. But also, you can see what they export. And you see that Chile exports refined copper, copper ore, pig meat, and grapes. Now, let's look at what Korea exports to Chile. And what Korea exports to Chile are cars, delivery trucks, vehicle parts, machines, plastics, and so forth. So Korea exports only $2.5 billion to Chile. And since Chile exports $4.6 billion, that means that Chile has a positive trade surplus with Korea. But now, if I look at the things that Chile exports to Korea, I realize that these are mostly atoms. If I look at the things that Chile imports from Korea, these are the ways in which these atoms are arranged. So even though Chile has a positive trade surplus with Korea, it has a negative imagination surplus. So the question is, well, why do we bother to crystallize imagination? We're the only species in our planet that builds cars, makes figurines of glass, creates televisions, uses iPhones and so forth. There must be a benefit that comes from our ability to create products. So what's that benefit? So what I'm going to do here is I'm going to ask you a question. And the first question I'm going to ask you is, well, how many of you use toothpaste today? So raise your hand if you use toothpaste today. Okay, and now keep your hand up, because I'm going to ask you another question. Now keep your hand up only if you know how to synthesize sodium fluoride. So what does that teach you? Well, you use toothpaste today, but you don't know how to synthesize sodium fluoride. So what this is telling you is that a product as simple as toothpaste is not just a bunch of goo inside a tube. What it is, it's actually a vehicle for the practical uses of knowledge and know-how. A product like toothpaste allows you to eventually, access the practical uses of knowledge that reside in the nervous system of other people that you've never met and that were required to create that, tube of paste that has these magic properties that allow you to clean your teeth and so forth. But the thing is, obviously, we cannot equate all, physical order to economic value, because there's something more that is involved in the creation of products. When we create products, we're creating economic value by creating order. But also we're creating economic value because some of the things that piggyback that order are context specific to the use of that product. So think of aspirin. And aspirin, from a statistical physics perspective, actually embodies very little order. It's a very simple, a very small molecule. But what you access when you access the aspirin is implicitly the knowledge on how do you prove that this is a molecule that has a benefit in your body. How do you know that that is not bad for you? So you're getting implicit access to knowledge about the scientific method, but also about the process of chemical synthesis, and about all of these other things, that are implicitly carried, by the transfer of this little crystal of imagination. So to conclude this section, I'm going to tell you one more story, which is a story that I borrowed from Norbert Wiener's book, The Human Use of Human